It is in the cold and remote parts of space that the history of the world lies. For centuries, astrologers have looked to the heavens in hopes of discovering the mysteries of the universe. In recent years, however, progress has been made ahead of the launch of the James Webb Space Telescope, JWST. The successor to the Hubble Space Telescope promised to look deeper into the universe than ever before, revealing not only the origins of stars and galaxies, but also the nature of the period. As the world watches on December 25, 2021, JWST will begin its journey, embarking on a mission to redefine the boundaries of human knowledge. But the true extent of his power was hidden in the unknown, waiting for his tools to reveal secrets beyond our imagination. This is the telescope that will answer the question that has puzzled mankind for thousands of years: are we alone in the universe? The James Webb Space Telescope, JWST, promises to unlock deeper and deeper questions about life. Its advanced technology allows us to look back billions of years to the origin of the universe. However, its ability to identify exoplanets with chemical signatures of life offers the tantalizing hope that, maybe, we're not alone in this broad spectrum. What groundbreaking discoveries are hiding in the stars, waiting for JWST to discover? To understand the true significance of the James Webb Space Telescope, JWST, one must first understand its predecessor, the Hubble Space Telescope, HST. Launched in 1990, Hubble changed the way people see the world. For the first time, astronomers have access to images of distant galaxies, nebulae and stars, free of the effects of cosmic fog. Hubble's pioneering contributions are immeasurable, from determining the speed of the universe's expansion to capturing the spectacular impact of the comet and Jupiter. The famous deep-field images, which showed the light of galaxies billions of light-years away, gave us a glimpse of the early universe and set the stage for future space exploration. Despite its achievements, the Hubble Space Telescope has limitations. The 2.4-meter mirror, although revolutionary for its time, limited the telescope's ability to gather light from distant parts of the world. In addition, Hubble was designed to observe the ultraviolet, visible and near-infrared parts of the spectrum. As astronomy developed, a new type of telescope was needed, one that could observe the universe in the infrared spectrum. This allows scientists to see through clouds of dust in the sky and study the early galaxies, whose light has shifted into the infrared spectrum due to the expansion of the universe. The idea for the James Webb Space Telescope was conceived in the early 1990s, even before Hubble reached its full potential. Named for James Webb, who served as NASA administrator during the Apollo era, JWST was envisioned as the next great observatory, a telescope that could look back even further than Hubble. It was the instrument that captured the light from the first stars and galaxies that formed after the Big Bang. However, the design of that telescope presented unprecedented technical challenges. Unlike Hubble, which orbits the Earth at an altitude of 570 kilometers, JWST must be far from Earth, about 1.5 million kilometers from Earth in a place that's known as the second Lagrange index, L2. This remote location provides an environment with little protection from Earth's heat and light, but means that the telescope cannot be operated or adjusted by astronauts, as said Hubble. For this great mission, everything must be done right from the beginning. One of JWST's main goals is to observe faint and distant objects from the early universe. To achieve this goal, a mirror larger than Hubble is needed. Engineers created a split mirror design, consisting of 18 gold-plated hexagonal beryllium segments, that make JWST 6.5 meters across, nearly 3 times the size of Hubble's mirror. This large mirror had to be folded up to fit inside the rocket when it was launched, and opened and the telescope reached its final destination. After years of careful planning, delays and high cost, the James Webb Space Telescope will be launched on December 25, 2021. But the real test of this mission is yet to come. Over the next 30 days, JWST began a series of complex and detailed deployments. The telescope's shield, about the size of a tennis court, was the first large part to be released. This sun shield is essential for blocking heat and light from the sun, Earth, and Moon, so that the telescope's instruments remain at their optimal operating temperature, just a few degrees above absolute zero. A defense installation consists of hundreds of machines and thousands of individual components. One mistake can ruin the whole mission. Fortunately, everything went according to plan. Once the shielding was in place, the 18 mirror segments began to unfold and align with nanometer precision, a process that took several months. By mid-2022, the telescope will be fully operational and ready to begin its mission to explore the world. The first images taken by JWST stunned the world. For the first time, people can see the world in the infrared spectrum with great clarity and detail. These early images showed a world more powerful, complex, and thought-provoking. One of JWST's primary goals was to observe the first galaxies that formed after the Big Bang, more than 13 billion years ago. These galaxies are so distant that their light stretches into the infrared spectrum, a phenomenon known as redshift. Although Hubble can only look at these ancient objects, JWST's infrared capabilities allow it to see them in the past. In its first year of operation, JWST made many discoveries. One of the most important is the discovery of galaxies a few hundred million years after the Big Bang. What is remarkable about these galaxies is their size and complexity. Contrary to previous theories that early galaxies were small and evolved slowly over time, JWST revealed that some galaxies are larger and more evolved than previously thought. This discovery has prompted astronomers to rethink their models of galaxy formation and evolution, as it suggests that some galaxies may have formed and matured much more rapidly than previously believed. This revelation, early massive galaxies, has profound implications for our understanding of the universe. For years, astronomers believed that the first galaxies were small, chaotic systems that slowly merged over time to become the massive structures we see today. However, the JWST's observations challenge this view, suggesting that galaxy formation in the early universe may have been far more dynamic and complex. This discovery has forced scientists to revisit long-held assumptions and develop new models to explain how such large galaxies could have formed so soon after the Big Bang. Another recent JWST discovery is the discovery of the cosmic web, the vast network of strings connecting galaxies across the universe. These filaments are made of dark matter and gas, and serve as the scaffolding on which galaxies form and evolve. Although the existence of the cosmic web was known before JWST, the power of the X-ray telescope allows scientists to see more information than ever before. JWST's observations have provided new insights into the universe's macrostructure and the role of dark matter in its creation. Dark matter, which makes up most of the universe's mass, is one of the great mysteries in modern physics. Although we cannot observe it directly, we can determine its presence by its physical effects on what we see. By studying the cosmic web, JWST has provided new clues about the nature of dark matter and its role in the formation of galaxies and other cosmic structures. JWST's ability to observe in the infrared has also revolutionized our understanding of star formation and evolution. Stars appear in thick clouds of air and dust that block visible light, making it difficult to observe the early stages of formation. However, infrared light can penetrate these clouds, allowing JWST to view the star nurseries with unprecedented clarity. One of the telescope's first targets was the Orion Nebula, a star nursery about 1,344 light-years from Earth. JWST images showed hundreds of stars, some still embedded in their parent clouds. These observations have led to new insights into the nature and evolution of stars, including the processes that lead to the formation of planetary systems. In addition to studying the birth of stars, JWST has also captured stunning images of dying stars and the nebulae they form. These observations shed light on the final stages of a star's life, including the formation of white dwarfs, neutron stars, and black holes. By studying these processes, JWST has helped astronomers better understand the life cycles of stars and their role in creating the universe. One of the most spectacular images taken by JWST is the Tarantula Nebula, a large star-forming region in the Large Magellanic Cloud, a galaxy in the Milky Way. The Tarantula Nebula is home to some of the most massive stars ever discovered, and JWST's infrared observations have provided new insights into the shape and evolution of these stars. Telescope images showed a network of gas and dust and stars in different stages of formation. Some of these stars are so massive that they end their lives in spectacular supernova explosions, leaving behind neutron stars and black holes. JWST's observations of the Tarantula Nebula have helped astronomers understand how giant stars form and how they play a role in the formation of the universe.